So if you look at my slides, yeah, so this is a very quick summary of solid, liquid, and gas. Okay, and then if you see these words here, okay, rigid, and not rigid, all right? Most of the time, it's not inside PSLE, right? You only need to know fixed volume, fixed shape, okay? And then this part here, because I took this picture from the internet, right? Okay, so what can you replace with instead of using the word squashed? Like what we mentioned earlier, is about the compressibility. All right. So quick summary, just to let you recap what you have learned before. Thank you, Wela. Okay, so did you learn about something like this? Yeah. Okay, everything has mass, right? We learn about the solid, liquid, and gas. They all have the mass. Even us, we have our own mass as well. You have not learned about weight. You have, I think you will only learn about it next year unless your school decides to teach it early, right? Under forces. So our mass will never change, but our weight can actually change. How does it change? It depends on the gravity pull in that particular place that we are in. And what do I mean by that? Okay, it's not about, oh, I'm in Singapore, then when I go to Malaysia, my weight will change. No, no such thing. Okay, your weight changes according to the planets you're on. For example, in this case, on Earth, all right, this person has these mass, 120. Okay, on Earth, his or her weight is actually 1,200 newtons. But when he or she goes onto the moon, the mass stays the same, right? But the weight is different. You're going to learn about this next year. You'll learn more about this in secondary school also. Okay, so take note, mass cannot change. All right, whatever is inside that particular object stays the same. Okay, unless something is done. And we are going to talk about it today in our worksheet. So let's look at the first question here. For honor, let me just check. How many of you have not done this? Okay, I am downloading your responses. So far, I can see a few of you did this, right? Jia did it. Casey. Kenny's also completed. Jessian, Jiang Kun, Irene, Vinuli, and Wheeler. Very good. So all of you did this. Good. Now, remember, I like to look at your responses, right? And I like to go through your responses with you also. One minute. Hey, finally. This thing is not working so well. Just give me 1 minute, okay? I need to do answers nicely. So later I can show you your responses. All right. so that you can see where you have gone wrong when I go through the questions. Let's try 50. Okay. Those of you who have not done your work, right? Okay, take note, you're supposed to be doing this so that I can see your answers, and then I can also comment on your answers when we are having our tutorial. All right. Okay, so let me see. I have the responses here. Okay, so let me check your answers. One of you got this wrong for question 1. The rest of you all got it correct. So let's take a look. Now, when Christy poured water into a beaker which contained some stones, some air bubbles were seen moving upwards. Where did the air bubble come from? Where did the air bubble come from? Let's see. Let's see whether you know this. All right. Where did the air bubble come from? When someone poured the water into the beaker, you see the air bubbles are here, right? So where do you think it came from?
The air bubbles came from the space in between the stones.
The space in between the stones. Okay. So stones is in a particular state of matter. What is it? What is the state? These are solids, right? Correct. And they probably have an irregular shape, isn't it? Okay. And for solids, it's fixed, right? So you can't mold it to change its shape. So when it's irregular, there's definitely going to be some spaces between them. Do you agree? Okay, so these spaces can trap air. When I pour water in, or let's say this person, Christy, poured water in, okay, because air, it is actually less dense, right? So it will tend to want to escape. So it escapes, all right? And then it actually gets lost into the environment. After a while, she saw that the water level was lower than the start. Why is that so? Yeah, Jiaqi, you're right. The air that was trapped, okay? The air that was trapped between the stones, you know? Yep, Xiangkun also said the space between the stones. Yep, Irene and Vinoli told me that, you know, the stones are solids. Okay, because of the fact that they may be having irregular shapes. Okay, if you look at the stones out there, you see that this piece of stone will be different from the other pieces of stone that you are seeing. So the air that is trapped there will escape. And why is it that the volume or the water level, I shouldn't say volume, I should say water level was lower? Okay, all of you chose the answer C. All right. Okay. Jiaqi, I saw that you chose a separate, a different answer from the rest. Would you like to explain what you're thinking about? Jiaqi, you can type into the chat. Okay. Water has been compressed. That is not true. And we know that liquids cannot be compressed. Okay. Solids cannot be compressed. Now, so you're left with C and D. All of you chose C except one person. You guessed it. Okay, Jiaqi actually chose D. The air bubbles in the water decrease in volume. What does that sound like? It sounds like the air bubbles have been compressed, isn't it? You all agree? This statement sounds like the air bubbles are being compressed. That's why there's a decrease in volume. But do you think this is the case here? It is not. Okay, Jiaqi, the very important thing is for you to observe. What did you see? The air bubbles actually were seen moving upwards. What is the intent of the air bubbles to move upwards? To escape the water, to leave the water. Clear? Jiaqi? So after leaving, the water is no longer there. So it did not decrease in volume. It escaped. All right. So question 2, Alexa poured some water into a measuring cylinder. How many of you have done this in school? I have. I even asked my students to do many of this in school. Good. So you have done this, right? You were given the measuring cylinder. Okay. Your teacher asked you to pour certain amount of water in, right? And then you're supposed to take the reading. So after taking the reading, you record it down onto your worksheet. Then put in maybe plasticine or maybe an eraser into the measuring cylinder. We tried that in our experiment. Okay, but in this case, it's 3 identical marbles. Tell me, what is this word identical? What do you understand by the word identical? Yep. Okay, good. Some of you say that it's the same thing. Identical is same. Okay, what do you understand? Oh, okay, what do you mean by same? What do you mean by same? In terms of what? Equal size, okay, equal in size. Okay, equal in shape. Same type, same size, similar in shape and volume. Wonderful. Okay, so it cannot be like one marble is bigger, the other marble is smaller, right? No, they are all the same. That means they have the same mass, they have the same volume, they have the same shape. Okay, so now take a look. Okay, sorry. So now take a look. She put it in and then she noted the volume was now Y cm cube. Okay, so there's an increase. The increase is here. So you can see that if I were to draw. So this will be the increase in the volume, right? So next, she put 2 identical metal cubes into the measuring cylinder and she recorded the new volume to be Z cm cube. So draw the line here. That means this will be volume of the metal cubes. This one will be volume of the marbles. So how do you calculate the volume of each marble and each cube? Each means 1. All right. So answer, let's see. Yeah, I have also one different answer here. Okay, so how do we do this? How do you find the volume of the marble? So this is the volume for the marbles, right? And I need to use Y minus X to find the 3 marbles volume. Agree? But if I only want one of them, I need to divide by 3. Yes or no? Now, talk about the metal cubes. Metal cubes, when added in, the volume is Z. So I use Z minus Y divide by 2. Let's see. Casey, do you understand this now? I think you were a little bit confused, right? Yep. So when I go through it step by step review, can you understand better? Good. Okay, so answer is actually B. Question 3. Right. We have 2 differing answer. No, more than that. 1. Yep, 2. 2 person gave different answer. So let's take a look. Alia took a sponge, dip it into a container of water as shown. What is a sponge? What is a sponge? Have you all seen or used a sponge before? Yeah, where do you use it actually most of the time? Where do you use it? In the kitchen. Good. How many of you use it in the shower? You know, they are the shower sponges, right? How many of you use it when you help your daddy